All right, so this is number 61 out of chapter 2.3. This is an example where they ask us to factor this completely by finding the zeros. Now, initially, we need to find those zeros graphically. Okay, so we need to find enough zeros, okay, to where we can use synthetic division. Okay, to get to a quadratic. Now, once we get to a quadratic, we can use either factoring or the good old quadratic formula. So in this particular case, I see that I have a t cubed. Okay, my big power, or the degree of my polynomial is 3, so I'm going to need to divide once to get it down to a squared term, and then I can take over with one of my easier methods. Now, the way you're going to want to go about this is to go ahead and plug it into your calculator. Hopefully you can see that okay. Let me zoom in a little bit on it, actually. All right, so looking at the calculator here, you notice I went ahead and I used x's. There's absolutely no reason, try to see if I can focus up a little bit more. There's absolutely no reason that you would need to use a t. You can use an x just as well. It's just, it's easier. It's your input. So I go ahead and graph this. Okay, and I can see here that per this problem, I have a couple different, I have 3 zeros that I can locate. I have one here, and one here. Now, what we went over in class is we have a couple options as far as how we can go ahead and verify the exact zeros that we want to be looking for. Well, one, if we're lucky, we can simply look at the table and see if we can find where y is equal to 0. Now, I'm looking through, and looks like y ends up equaling 0 right there at -2. So we kind of lucked out in this particular case. We kind of lucked out here in that y did go ahead and equal 0. So we have our x-intercept, and we can see that x is equal to -2. Now, there's a couple other options that you have if that's not the case. Now, one of the things you can look at is you can look at your y's. Okay, if you notice from 0 to 1, or I'm sorry, from 2 to -6, well, if it's going to go from 2 to -6, then y is going to have to cross the x-axis. It'll have to be 0 at one point. So one place that we can look for zeros would be between 0 and 1. Okay? And you can continue to do that. Now, if you're not lucky and it's not in the table, let me show you what you can do as well. And a bit of this is just going to be guess and check. Okay? You can also go and hit second, and then the trace button will get you to calculate. We want to calculate the zeros. So we're going to go right over here. Now it says left bound, so you're basically telling the calculator, I don't want you to look any further to the left than that, and I don't want you to look any further to the right than this. Okay. If you hit enter, you now see that you have a 0 at x equals -2. So that's the first one we're going to use. Okay. We're going to use x equals -2. Now, since we're using it in this way and we're not talking about a factor, we're going to use this as our k. So we're going to have -2 here, and then we're going to set up our synthetic division. So we have t cubed has a 1 for a coefficient, squared has a 2 for a coefficient, the first power has a -7 for a coefficient, and then our constant is 2. Okay. I did skip a step, and I apologize. The other thing that you should have done was to actually list out all the possible rational zeros. And that gives you a little better an idea of where you should be looking. And the way you do that is you take the factors of your constant here, 2, so plus or minus 1 and plus or minus 2. That's going to be on the top. And you put that over the factors of your leading coefficient, which in this case is 1. So we'd have plus or minus 1. So all of the possible coefficients would be in there, and if you notice, we have 2 over -1, so -2 was one of the possibilities. All right, go ahead and drop down your 1. -2 times 1 is -2. Add them up, we get -4. -2 times -4 is -8. Okay, add them up, and we get, oh, I'm sorry, it's +8. Add them up, and we get +1. -2 times times +1 is -2, and lo and behold, we do know this is a factor because we have a remainder of 0. Okay. Now looking at this example, we know we just divided by 1, so our power will decrease by 1. So I can write this out as a product of factors in this case, in which case h of t will equal, well, if this is a -2, that means that x is equal to -2, which means one of my factors, if I add 2 to both sides, okay, one of my factors is in fact x plus 2 equals 0. So I can write h of t is equal to x plus 2 times x squared, with that 1 as a coefficient, minus 4x, -4 as a coefficient, plus 1. Okay. Now for this particular part, you would go and see if this is factorable. So looking at it, I know that I'm going to have a 1 up top here, and I'm looking for two numbers that multiply to equal 1 and add to equal -4. Sorry, lights turned off on me. So in this particular case, we can see fairly clearly that that's not going to work. So this, in fact, is factored completely. But if you wanted to go a step farther and find the remaining zeros, we can use the quadratic formula. X is equal to -b, so -4, okay, plus or minus the square root of b squared, so -4 squared, minus 4 times a, which is 1, times c, which is 1, all over 2 times 1. Okay. Now, doing a little math here, we can see that this will end up being 4 plus or minus, well, this is 16 minus 4, so on the inside we're going to have square root of 12 all over 2. Okay. We can actually go ahead and pull a 4 out of this, so we would get 4 plus or minus 2 square root 3, just reducing that down over 2. Now I can cancel this 2 since I can distribute the division to both of these, okay? And we get that this is in fact equal to 4 plus or I'm sorry, we just divided it by 2. We get 2 plus or minus square root 3. Okay? And that 2 canceled with the 2 and with the 4, and we're left with 2 left over. So our roots in this particular case end up being x plus 2. Okay? And oh, now that I think of it, what we can do here as well. So this technically is not factored completely because we can factor it a bit farther. Here we have x plus or minus the square root of 3, so we can rewrite that as x is equal to 2 plus or minus or plus the square root of 3, and x is equal to 2 minus the square root of 3. Okay, if I go ahead and subtract 2 and subtract square root 3 from both sides, okay, then we get x minus 2 minus the square root of 3 is equal to 0. Those all cancel out. And if we do the same thing here, we would get x minus 2 plus square root 3 is equal to 0. Meaning that this is a factor, this is a factor. So we could actually go a step farther here and write that h of t is in fact equal to x plus 2, our original factor there, times the factor here, x minus 2 minus the square root of 3. Okay, that was just right here. and times our last factor, x minus 2 plus the square root of 3. Now my work got a little bit jumbled here, but we stayed pretty organized. And if you multiplied all these out, go for it if you feel like it, you would get right back to our original function.